Hi friends, in the previous video I was already explained the basic introduction of 8051 microcontroller, right? Now let us see in this particular video I am giving you brief idea about the block diagram of 8051 microcontroller. So nothing but the architecture of 8051 microcontroller. Let us see detailedly here. See here, this is the diagram, right? I will highlight it. Right. See the topic 8051 internal block diagram. Okay, if you observe carefully, so we have many registers are present, many blocks are there. Let us see detailedly. In the introduction part, I was already explained. 8051 microcontroller mainly contains 4 ports, naming as port 0, port 1, port 2, and port 3. 4 ports are there. Okay. So in addition to that, 8051 may ready to perform many operations. Internally it is having RAM memory, ROM memory. See, 8051 block diagram itself having a RAM memory, then ROM memory. Okay, and many registers are present. Let us see detailedly how they are connecting first. Later we'll see functioning of each one detailedly. Okay. Right. Let us see first A register. It's an 8-bit register. A register is present. B register, another 8-bit register. So A register also call it as a accumulator register. Assume this is a internal bus of 8051. Right? Internal bus. So now this internal bus is connecting to many of the blocks. Here this is internal bus. Now assume this is ALU. It's a arithmetic and logical unit. So now these two are temporary registers. These two registers are used to store data temporarily. Assume this is PSW, program status word of 8051, also call it as a flag register. It is also 8-bit. So now this is a RAM memory of size 128 bytes. For accessing this RAM memory, we need RAM address register. Now this is ROM memory. Size is 4 kilobytes. For accessing ROM memory, we need a ROM address register, nothing but program address register. So here also some more registers are there. Stack pointer. Okay, it is also 8-bit register. Program counter. It is a 16-bit register. PC incrementer, one more register, and DPTR. It's a data pointer register. It is also 16-bit. So DPTR and PC, these two are 16-bit registers. Okay. Then later timing and control block. So this timing and control, especially control block will control. So the operations, let's suppose whether the 8051 is performing memory read or memory write or serial port operation or timer operation or interrupt operation or only IO operation. Okay, which operation will perform, that is controlled by timing and control block. So having set of pins, and this is oscillator. I already mentioned 8051 having on-chip clock generator oscillator having 2 pins, call it as a XTAL1 and XTAL2. It's not the XTAL1 and XTAL2. These two are 2 pins of oscillator, and these 2 pins are connected to externally crystal oscillator for generating the required clock frequency. Okay, then there is an instruction register. Okay, and there, in addition to general registers, there are some special functional registers. Naming as PCON, SCON, TMOD, TCON. So PCON is a program. No, these two are serial port control registers. SCON is serial port control register. PCON is it is also programmable control register. We'll see detailedly. Okay, in the last video of 8051, we'll see detailedly SCON and PCON. These two are control registers, especially serial port control registers. Okay, TCON and TMOD, these two are timer mode control register. These two are serial port control register, and these two are timer mode control registers. TH0 and TH1 is timer higher 0 register, timer higher 1 register, timer lower 0 register, timer lower 1 register, because we have 2 timers, timer 0, timer 1. So those timers are also divided into lower and higher. So higher 0, higher 1, lower 0, lower 1. SBUF is a serial buffer register. I and IP are interrupt registers, nothing but interrupt enable register and interrupt priority registers. Okay, like that we have 2 serial port registers and 2 timer registers and 4 timer registers and 1 serial buffer register and 2 interrupt related registers. All are comes under family special functional registers. Okay, now See here, there is a one block interrupt operations, serial port operations, timers, memory read and memory write. All are controlled by port 3 because port 3 having 8 pins. So now in addition to IO operation, port 3 performing many other operations like interrupt operation, serial port operation, memory read or memory write, timer or counter operations, all are performed by port 3. Okay. And similarly here also each port is ready to perform either input or output. If it is input, we are calling as a buffer. If it is output, we are calling as a latch. Like that, latch 0, buffer 0, latch 1, buffer 1. Similarly for port 2 also latch 2, buffer 2. Port 3 also latch 3, buffer 3. Okay. So like that various blocks are present and they are connected to internal bus of 8051. Now coming to blocks in especially if you take port 0, so except port 1. So here port 1 is purely for IO operation. Okay, port 1 is not multiplexed port. So no other operations are performed by port 1. Only it will perform IO operation. Means port 1 is ready to perform either input operation or output operation. If it is input, we are calling as buffer. If it is output, we are calling as a latch. But whereas port 0, it is a multiplexed port. Port 0 performing not only IO operation. All 8 bits are used not only for IO operation. These 8 bits may also having multiplexed address and multiplexed lower address and data lines. So why we go for multiplexing of pins? Because of multiplexing of the pins, number of pins are saved and we can reduce the space occupied by the 8051 microcontroller easily. For that we use multiplexed arrangement. Here because see now these 8 pins performing 2 different functions, either IO functioning or AD0 to AD7. In that AD0 to AD7 also we have A0 to A7 and D0 to D7. So see here if you take only IO we need 8, only address we need 8, only data we need 8. Total 24 different pins are required. But port 0 pins performing 8 IO operations, similarly 8 address lines operation and 8 data lines operations because of multiplexed nature. Okay, this port 0 having finally 8 IO lines and lower 8 address and data lines are also present in this port. Port 1 only pure IO, no other multiplexed operations here. Whereas port 2 performing 2 functions. Port 2 8 pins are used to perform IO operation as well as 8 address lines also. This port also multiplexed port. It also contains 8 address lines as well as IO, ready to perform IO also. Port 3 total 8 pins are there. These port 3 pins are also used for 8-bit IO operation. In addition to that, port 3 individually bits are also performing multiplexed operation. So except port 1, remaining all ports are multiplexed ports. Means performing more than one function. Okay, in addition to IO, performing other functions also. But port 3, we have interrupt related pins are present, timer or counter related pins are present, serial data related pins are present, read write pins are also present. So all are comes under port 3. That's why interrupt, serial port, timer and memory read, memory write all are connected to port 3 related port. Okay. Like that we have ports and there internally which pins are connecting. So in the coming video I will explain the pin diagram of 8051. In that let us see functioning of each port detailedly. Okay. Now coming to here registers. If you see A register, also called it as accumulator register, it is an 8-bit register. And this accumulator register mostly stores the it is act like a destination register for all arithmetic and logical operations. B register is another general purpose register and it is used in all the general purpose operations. It is also an 8-bit register. These two are temporary registers, store data temporarily. Coming to ALU, it's arithmetic and logical unit, and this unit perform all arithmetic and logical operations of size 8-bit only. And various arithmetic operations are like addition, subtraction, multiplication, and division, and various logical operations are like AND logic, OR logic, XOR, and NOT. Okay, all those operations are performed by ALU. After ALU operation, there is a chance of getting the flags. Those flags are observed in the program status. We would also call it as a flag register. Then we get the result. Okay, after getting the ALU operation. Now, after we are observing the program status word and getting the results, those results are stored into RAM memory. RAM is ready to perform read and write RAM memory. For selecting the RAM memory, we need RAM address register. So RAM address register is used to select the address of the RAM memory. Okay, right? Like that, instructions are executing, and what is the rate of executing the instructions are decided by oscillator. Based on the oscillator frequency, instructions are executing with a particular clock frequency range. Okay, then other is stack pointer. Stack pointer is always performing all stack operations, and stack pointer point out stop of the stack. Okay, for push and pop operations, stack pointer register is used, and if any reset is occurred, stack pointer is pointed out at the location 07H, and next instruction, next stack operation starts at 08H. Like that, stack pointer is an 8-bit register. Stack pointer point out stop of the stack. Then program counter, it is a 16-bit register, and program counter register point out the address of the current program executing, at which address current program executing, that information is present in the program counter register, and it is a 16-bit register. PC incrementer is another register, and for every instruction is executing, then PC incrementer is incrementing by 1. Then DPTR is a data pointer register, and data pointer register. It is also 16-bit register, and this register can be divided into two parts, DPL and DPH. Nothing but data pointer lower, data pointer higher. Like that, it is dividing into two 8-bit registers also if required. Okay, if you use DPTR completely, then it is used for 16-bit. Generally, this DPTR is used to access, especially internal ROM, because internal ROM size is 12-bit. So, because in order to select 12-bit also we need 16-bit register. So, generally for accessing internal ROM memory or communicating with external RAM and external ROM, generally we are using DPTR register. Okay, and it is divided into two 8-bit registers, DPL and DPH. DPL is data pointer lower byte, and DPH is data pointer higher byte. Okay, like that. Another is ROM memory. ROM memory, okay, this memory is used to performing only, we can read data from the ROM memory. So the address of accessing data from the ROM memory is decided by ROM address register. Okay, and all are the special functional registers. We'll discuss in the special functional register topic. We'll see functioning of each one separately. So there are two serial port related special functional registers, two timer registers, and two timer mode registers, and 4 are timer higher 0, timer lower 1, timer, okay, like that, timer lower 1, timer lower 0, timer higher 1, and timer higher 0. These 4 are also timer related registers. Okay, now these two are timer mode related registers, and this is serial buffer register, and these two are interrupt related registers, IE and IP. So all are special functional registers used for performing some special operations. Okay, so we'll discuss separately all these registers, okay, in the coming videos. Okay, like that we can analyze timing and control logic, controlling entire operation, whether the 8051 performing serial port operation, or timer operation, or counter operation, or interrupt operation, or IO operation, decided by timer and control registers based on the activation of corresponding signals. Here also AL is address latch enable, EA bar is enable access bar, or we can call it as external access bar also. Reset is another one. PSEN bar is program store enable bar signal. Like that, we have 40 pins are present in 8051. In the coming video, I will give you detailedly functioning of each pin. So program status word is also flag register of size 8-bit. So whenever ALU is occurred, then some of the flags that are present in PSW may affect. We'll see flag register and how many flags are there also in the register organization topic. Okay, so in the coming videos, I will give you pin diagram, then register organization and memory organization. In those topics, we'll see detailedly what are the various registers and what are the functions in detail. So I think from this particular video, you have clear idea about that, what are the various blocks present in the 8051 microcontroller and how they are connected to internal bus. Okay, and what is the role of ports, and what are the various operations performed by the port in addition to IO operation we observed. Out of 4 ports, only port 1 is not a multiplexed port. Remaining ports are multiplexed ports for saving the pins. Okay, and port 3 performing not only IO, many other operations. Okay, many other operations, so many operations it will perform. Okay, like that we can analyze the block diagram of 8051 microcontroller. Right. So thank you for watching this video. I hope you understand the basic architecture of 8051 microcontroller. Okay, so next video I will explain the pin diagram of 8051 microcontroller. Right. So thank you for watching this video. If you really like, please kindly share my video to your friends and subscribe my channel. Thank you.